Welcome back everybody with momentum. Today we are talking the first type of collision, perfectly inelastic collisions. So perfectly inelastic collisions are collisions where objects that were originally separated post-collision become stuck together after they have collided, moving as one unit. So for example, before, one object can be moving, not moving towards another object, and the other object can be moving, not moving towards the other object, and before the collision, but after the collision, they become stuck together and move as a single unit. This could be tackling somebody. This could be like a clay ball hitting a solid ball, like in this example. This could be you're running and then you jump onto a sled and then you start moving together with the sled. So stuff like that. Okay. In this kind of collision, momentum is conserved. Important to know. Meaning the amount of momentum the objects had before the collision is the same after the collision. Kinetic energy is lost within the collision. Okay. Here's the formula. So before the collision, there's going to be a certain amount of momentum, and then after the collision, that momentum is going to be the exact same, even though now both of these objects are going to be moving with the same velocity. If that doesn't make sense, as we do examples, it'll make more sense. Alright, here's a good video demonstrating this, and here's our first example. Alright, so a 1500 kilogram red car is moving at 30 meters per second to the right, when it rear-ended a 1200 kilogram car, which was moving 12 meters per second in the same direction. After the collision, the two cars get stuck together. What speed are the two cars now going after collision? So remember, the momentum at the beginning is equal to the momentum after the crash. So let's figure this out. So at the beginning, we have the red car, which is 1500 kilograms and it's moving 30 meters per second before the collision. The blue car is 1200 kilograms and it is moving 12 meters per second before the collision. After the collision, they get stuck together. Since they're stuck together, we can combine their masses. So 1500 plus 1200, and then they move together with a certain speed. I'm just going to call it V final. I'm going to use my calculator to simplify a few things. 1500 times 30 plus 1200 times 12, and we get 59,400 is equal to 2700 V final. I'm just going to do 59,400 divided by 2700 to isolate the V final. And yeah, V final is equal to 22 meters per second. Okay. B, what was the total momentum of the two cars before the collision and after the collision? Okay, so before the collision, let's see. We have the red car, 1500, going 30 meters per second. And then we have the blue car, 1200 kilograms, going 12 meters per second. Now let's calculate this. 1500 times 30 plus 1200 times 12. And we get 59,400, like last time. Kilograms times meter per second. Then after the collision, we have both of them moving up with the same speed. So 1500 plus 1200, going with the speed of 22 meters per second. I'm going to put it into my calculator. And then we get, oops, sorry. Anyway, I know what the answer is, but times 22, and we get 59,400. So anyway, this just shows momentum is conserved. Okay, so right before the collision and right after the collision, they have the same amount of momentum. Momentum is conserved. Okay, moving on. A 2,000 kilogram red car is moving at 25 meters per second to the right when it rear-ends a 1,200 kilogram car, which was moving at 50 meters per second in the same direction. After the collision, the two cars get stuck together. After the collision, how would the blue car be moving? A, faster, B, slower, C, the same speed. You should say, like, after the collision, how would a car be moving compared to before it collided? Yeah. And it takes some time to think about it. Pause if you want. But it should make sense that it's going to be going faster. Okay? This is hitting into it. Now they're both moving together. It was going 15, and it's kind of getting like a boost going more. It won't go more than 25, but it'll be more than 15. Okay, moving on. A 2,000 kilogram car is moving 25 meters per second to the right when it rear ends a 1,200 kilogram car, which is moving 15 meters per second in the same direction. After the collision, the two cars get stuck together. After the collision, will the red car be going A, faster, B, slower, C, the same speed? So similar thing, but we should know when this red car hits this car and they start moving together, it is going to go slower than 25 meters per second. Faster than 15, but slower than 25. So B, slower. Okay, moving on. On a touchdown attempt, an 80 kilogram running back runs to the right with a speed of 4 meters per second. Okay, let me just write this down. 4 meters per second, 80 kilograms. Okay, a 110 kilogram linebacker moves toward him going 3 meters per second to the left. When they collide, the linebacker wraps his arm around the running back as they move together as one unit. What speed are the football players now moving after the collision? Okay, so part A. So let's just think about the momentum before and after the collision. So before the collision, we have the running back, which is 80 kilograms, moving to the right 4 meters per second. Then we have the linebacker, which is 110 kilograms, moving to the left, which is negative 3 meters per second. He wraps around them, moving as one unit, so this is going to be 80 plus 110, and then going with a certain speed, which we need to figure out. So let's simplify this. 80 times 4 plus 110 times negative 3. And we get negative 10 is equal to 190 VF. Okay, so then we get the final velocity divided by 190. Okay, and we get negative 0.05 meters per second. Okay. However, it's asking for the speed, so speed doesn't include direction, so we can just say 0.05 meters per second. Part B is, which direction are they now moving after the collision? Okay, so even though part A didn't ask for direction, this negative implies that after the collision, they are going to the left. Okay, which means after they collide, they're going to be moving this way, which also means this guy had more momentum than this guy. Okay, moving on. Another cool video. A bullet is traveling 200 meters per second when it hits the block of wood of 1.2 kilograms and embeds itself into the wood. After the collision, the bullet and block slide together. In which case would the bullet and block have slid together faster after the collision? If A, the bullet had more mass, B, the bullet was traveling faster, C, the block of wood had less mass, D, both A and B, E, all of the above. So if this had more mass, that means it would have more momentum. If this had more velocity, that also means it had more momentum. If this had less mass, that means that when it collided, it would be going faster. So it would be E, all of the above. Okay, moving on. A 0.04 kilogram bullet traveling toward a block of wood that is at rest. When it hits the block of wood of 1.2 kilograms, the bullet embeds itself into the wood. After the collision, the bullet and the block slide together at a speed of 3 meters per second. How fast was the bullet moving before it hit the block of wood? Okay, so let's think about this. The momentum at the beginning equals the momentum at the end. So this is 0.04 kilograms, and we don't know how fast it's going. That's what we're looking for. We know this is 1.2 kilograms, and they slide together when the bullet is in here at 3 meters per second. Okay, so let's figure this out. We have 0.04, that's the bullet, traveling with some speed that we don't know. Then we have the block of wood, which is 1.2 kilograms, and before the collision, it's not moving, so it's just a 0. After the collision, they combine 0.04 plus 1.2, and they move together at a speed of 3 meters per second. So let's simplify things. We have 0.04 times V is equal to 1.24 times 3. Sorry, I should just put that into my calculator. Okay, 1.24 times 3. So 3.72. 3.72 meters per second. So I'm just going to do 3.72 divided by 0.04, and we get velocity is equal to 93 meters per second. Okay. So that's how fast the bullet was going before it hit the block. Okay, moving on. A 45 kilogram running back runs to the right with a speed of 9 meters per second. So let's see, 45. A 120 kilogram linebacker moves toward him at 3 meters per second. When they collide, they become intertwined and move together as one unit. Which direction do they move together? So with this question, we have to find which one has more momentum. Because since they get intertwined, the direction it goes depending on which one has more momentum. So let's figure that out. I'm going to do 45 times 9. This guy is 405. The other one is 3 times 120, which is 360. So we should know that since this guy has more momentum, that we are going to move to the right. Okay, moving on. A block of clay with a mass of 4 kilograms is moving to the right at 3 meters per second. It collides with another block of clay that has a mass of 3 kilograms and moving with a speed of 4 meters per second to the left. When they collide, they merge together. In which direction do they move? Okay, so let's write this. 4 kilograms going 3 meters per second. And then this one is collides with another black clay that has a mass of 3 kilograms moving 4 meters per second to the left. So what direction it depends on is which one has more momentum. This one's 3 times 4, which is 12, and this one's 4 times 3, which is 12. So they have the same exact momentum, meaning when they hit each other, they don't move. Okay. Alright guys, so that's pretty much it for perfectly inelastic collisions. Next time we're going to be talking about inelastic collisions, so I look forward to seeing you with that. Thanks for watching everyone. Bye.